Yeah, I hope the presentation is visible.
Madam.
Yeah, thank you so much. So great morning to all of you. I hope you all are doing great, whatever you are doing and from wherever you are doing. I hope you are taking proper care of yourself, because these are challenging times for each one of us, and it's very essential to take care and abide by and adhere to the instructions by government and state government. Right? So, without taking much time, let me first thank Alagappa University and Department of International Business, Vice Chancellor, Dean Sir, Dr. Muthuswamy, Professor Raghu, who all have been coordinating with me in uh, enabling this and giving me an opportunity to talk to all of you. You know, it's always a pleasure to talk to the fraternity where you have spent most of your time. So academia is always very close to my heart, and I try to grab every opportunity which allows me to interact with either faculty members or students or researchers. So in whatever time available, I just try to take up whatever comes my way, right? So the topic which I have chosen for today is Unchain the Blockchain. Now, what are we going to see here in the first introductory session? As I was aware that this is the first session, I have tried to keep it very simple. We will try to build up a foundation, which is the basic fabric of blockchain. We all know it, like the very idea of it is all known to us, because Vice Chancellors are also explained it. Deans are also explained it, and others also spoke about it. So we fairly know what is it all about, but we will try to give a very precise look at that, so that we understand what is it and how it functions, right? But at the same time, I know that I am addressing management faculties, so I'll try to abstract all the technical part of it and try to tell you like a story, so that you understand it very clearly, that what is happening within it and how it happens, right? And you will appreciate it also. And I must congratulate and compliment you for choosing this topic, because this is the future, you know. I mean, maybe banks may not have adopted it fully, they are skeptical about it, but then it is being used or will be used for other applications, for sure. Wherever you feel the data is critical and important, should not be mutated, everywhere this will be used. So it's very essential for us to look at it, understand it, and try to adopt it also, right? If you look at the Gartner's graph this year, 2020, you will not find blockchain there. Till last year it was there, but this year it has not been shown there. So does it mean that it has matured and surpassed that chart? No, it's not like that. But a very focused approach is being given to this, right? So this is, before we start, this is something about me. Of course, Dr. Muthuswamy has already introduced me, so this is redundant. I'll quickly skip through it. You can go to my website also, which is drnehasharma.in. As he has already told that I have done my PhD from IIT Dhanbad, which was the only Indian school of mines in our country. It has been renamed to IIT now. more than 21 years of experience in academia, and currently I'm working with TCS. So that's the reason academia is very close to my heart, you know. And very important thing which I did in my life and which is very close to my heart is I have formed a professional society, not for profit professional society, in the year 2018. And the name of the society is Society for Data Science. So we try to work around data, you know. So anybody and everybody who is interested in data is most welcome to come and work with us and contribute. I'm also an ACM distinguished speaker, IEEE senior member, got more than 50 plus books. Recently, one book has been published, authored book by name Open Data for Sustainable Community, wherein very interesting case studies has been covered on open data, you know, open data which is available at government site or maybe at corporate site, available for research. And couple of awards just to prove the credibility of my work, right? So coming to the topic, I would like to start with this graphic, you know. Now let's look at this graphic one by one. So you can see that in the first box, boss is asking his manager, so where should we focus this year? Boss is asking his manager, like, what is the area we should focus this year? So the manager who always tries to impress the boss, he says blockchain, because blockchain is something very new, right? And he tries to emphasize on his proposal. He says that it will change everything. Everybody is talking about it. The potential applications of blockchain are endless, and if we do not adopt it, we will be left behind. Okay, so when this manager gives so much of reason, the boss tries to ask him, so what is exactly blockchain is? Probably the manager does not have answer, and he tries to switch off the focus again, and he says, no, we can adopt artificial intelligence also. So what I'm trying to say, that everybody is talking about it, but we do not fully understand it. We understand it. I'm not saying that we don't understand. We understand the essence of it, but we do not fully understand it. What is the philosophy? How it functions? What are the puzzles which are being thrown? Why the puzzles are being thrown? How it improves the complexity? Why the infrastructure requirement is more? Why electricity bill goes up when we try to implement blockchain? So all those small things which we know, we will try to look at it in the fullest in this session. So that the subsequent lectures which you will have after my sessions for next 4 days and today also, this will act as a foundation of your understanding. So once the foundation is laid strong, I am sure you can take up to any heights from there. So my job is to lay a strong foundation, you know, today. I'm sure you will appreciate this session, and you will have good takeaways after this. So let's start. Now, if we have to understand what is blockchain, right? So we have to look at, we can't straight away start. I can't tell you the story from the center, you know. I have to take you back and start from the trailer, you know. If I have to narrate a movie story, I can't tell you from center and expect you to understand everything, right? So I have to take you back to the starting point of the movie, and then tell you the entire story. Then you will understand why it was required at all at first place. Why do we need it? Why it is so complicated? Why it is the amalgamation of so many technologies? You know, it's not one technology in isolation. There are so many technologies which are playing a role in blockchain, right? So to start with, we all know this is we have seen many times. So I am talking about industrial revolution, you know. How things have started changing. So we started changing from 18th century, where the first industrial revolution started, and there we started making use of steam, you know, and try to convert all the mechanical work which used to do in form of mechanized machine, you know. So all of that which we were doing it manually, we tried to build a machine which can do that. So we were trying to simplify our job, you know. So after that came Industrial Revolution 2. There we tried to make use of electrical power to build up the same thing in mass, you know. So first we tried to focus on mechanizing everything, then we tried to build up on mass production, and then we tried to make use of electronics, right? So that we can digitize. And then we tried to make everything smart, intelligent. So industrial revolution clearly shows you that you started with water, which was available, used it to your benefit, then you went towards electricity, then you made everything digital with the help of electronics, and then you tried to make everything autonomous with the help of intelligence, artificial intelligence, and so on and so forth. So this is how the industrial revolution has happened in the past, right? Now, if you look at first industrial revolution, second industrial revolution, and third industrial revolution, these were linear in nature. Why linear in nature? Because every industrial revolution has taken almost 100 years to mature and then make way for next industrial revolution, right? Whereas fourth industrial revolution was exponential. Everything happened in just 30 years, you know. Everything happened in just 30 years, and it is not stopping now. So many technologies, so many enabling technologies have come into foreplay, and all of this because of the advent of internet. So internet is not only helping many technologies to collaborate, integrate, but it is also helping it to generate one more technology. So technologies are, a host of technologies have come into the play, and they are collaborating to generate third technology also. So it's very fast, so much is there, you know. Now let's look at what these generation of technology is doing. It's certainly adding to scale, sophistication, and transformation in the way which we are functioning, you know, in the way which we are handling the data, in the way which we are looking at the data. Everything is, scaled up, you know. Everything has become very sophisticated. The transformation is happening just very quick, in just no time, you know. Let's look at eight essential technologies: Internet of Things, augmented reality, virtual reality, 3D printing, artificial intelligence, drone, robots, right? Now, all of these technologies either are generating data or collaborating together to generate data, or trying to analyze those data. Now, with the lethal combination of Internet of Things and artificial intelligence, you know, Internet of Things is contributing towards data generation. Rather, when I say this Internet of Things, I mean everything, you know, be it augmented reality, virtual reality, robotics, drones, everything is generating data. And once the data is generated, we are no longer dependent on business intelligence, you know, which was simple statistics applied on data to find out what data has to say. Now we have moved on from business intelligence to machine learning, which is artificial intelligence, right? Deep learning, neural network, all those things which are very advanced. Now, why do we need this? Because the data generation is so much. Now, with so much of data generation and so much of power to handle those data, we have to be very, very careful that interactions and operations employed by these technologies should be blazing fast and perfectly secure. So you have data, you have a power to handle those data also. But what you want to ensure that it should be fast and also secure. And that is where blockchain comes into play, right? Now, moving ahead, let me explain the entire thing. Of course, I'm going to take you through the details of it, but to start the story, let me tell you, try to tell you with a small example, right? See, these are four boys who wants to play cricket, gully cricket, you know, gully cricket. We all have been playing, our children have been playing, we have always been witnessing this, right? So these four boys have come to the street and they want to play cricket, and they define their own rules, you know, because it's a gully cricket, they want to define their own rules. Now, one of them says that if the ball goes to the shorter distance, it will be 2. If the ball goes outside the lane, it will be 4, and so on and so forth. And one of them, they says that if the ball goes on the roof of any building, then it is out. So they form some rule, and all of them accepts it, and they decides to play. Okay, they start playing. Now then they realize that they need to maintain the score of the game. They are playing, they are busy playing, so they want somebody to maintain the score of this. So they see that there's a boy standing there on the side of the road and watching them. So they feel that let us ask him to maintain the record. So they request him to maintain the record. Now the boy starts maintaining the record, like how many wickets have been taken, how many overs balled, how many runs have been made. So all he tries to make a record of it. Okay. But suddenly his ice cream is over and he is no more interested in keeping record. Okay. So one of them, he says that, okay, I'll give you another ice cream. You please continue doing it. Okay. Now, since this man has given him ice cream, he has got a bias towards him, and he starts recording a wrong information. Okay. So the data now, of course he's doing a job, but then there's no surety that data which is storing is correct, or the decisions which he is giving is correct. Okay, so he might get biased because somebody is feeding him some ice cream. Okay, so some favor he is doing, so he is giving the results in favor of him. Okay. Now after some times his mom comes and he takes him away. So this is a simple example of a centralized control. So when your data is at the centralized location, then it's quite possible that somebody can tamper it. Okay, so data can be no longer true source of information, or the person can go away, run away, disconnect from you with all your asset, which is in the form of data, right? So these are the drawbacks of centralized control. So they decide, why should we be dependent on any external? We all will record the data in our brains, and in case if we have doubt, we will consult each other, and whatever is the consensus, we will finalize that. Now in this scenario, if one of the boys feel that no, now my time is over, I have to go back and study, he will leave, but then data is still there with the remaining people. So data is not lost. So this is what is the idea of blockchain also. So you don't want data to be collapsed, data to be vulnerable to all faults, and data should not be lost also. So when you know that data is critical, companies are working around it. It has got potential to make you one of the best companies. So it has to be taken very, very seriously, and its security is paramount, right? So with this background, let me take you ahead and let's together try to understand what is the motivation for blockchain, right? So what is blockchain? I have just told you with a narration, a simple narration, but what is the motivation for the blockchain? Let's try to see. Let's try to trace its origin, from where it had started. So there was always a need of efficient, cost-effective, reliable, and secure system for conducting and recording financial and business transaction. Okay, so whatever transaction you do, you wanted always you wanted it to be efficient, cost-effective, reliable, and secure. So what you did, you made some effort to design an instrument of trust. Okay, so that means instrument of trust is something which will ensure that the trust between both the parties, when they exchange some value in terms of money, in terms of anything tangible, if they exchange, there is some trust built between them. Now, instrument of trust can be your money, can be the coin, can be a letter of credit, can be through banking system, anything. So instrument of trust can be anything which ensures that there is a trust between both the parties, right? Let's look at the evolution of instrument of trust, which is the change of the monetary system over the period of time. So you can easily see that initially long years back, we used to have a barter system. Barter system means you exchange. I have eggs in surplus, you have grains in surplus. Let's exchange. Okay. So you give me something which I need, and I'll give you something which you need. So we will exchange as per the requirement. Okay. Then came universal ledger, which was in the form of gold coins. So whatever you buy, you will pay some gold coin, and you will take the um, uh, item from that person or the vendor or the shopkeeper, or from somebody, right? Now gold coin, to carry gold coin was little risky. It was a total loss of everything, once your gold coins are stolen. I mean, it's all like that. Then came the situation of fiat money. Now fiat money is nothing but a paper currency which we are using right now also, right? All over the globe we are using it. So what happens, that equal amount of gold is kept in the bank, reserve bank, and the paper currency is made. So the paper currency which you are sharing or giving or exchanging tells you that this much amount of gold is kept in the reserve bank, and it says that the equal amount is being given to you or exchanged, right? So it was just for the ease of transaction, instead of carrying so much of gold, carrying paper currency is always better. Okay. Then came the era of digital representation, that is internet banking. Now, internet banking is like your bank. You can use the internet to transfer the money from one account to the other as per your requirement, right? Because of the e-commerce site, because of the online shopping and all those things, internet banking comes to a very handy thing. But it has always been observed that there is some hacking, or there is some malpractice. Just now, VC sir shared about, like, you receive a call and they ask for your password, code, and all those. They appear very authentic, but then they aren't. Okay, and those things. So online banking is prone to such things unless and until you are very careful, right? Then came the era of digital money. So this is the plastic money which we all carry in the form of debit card, credit card, and so on and so forth. And you don't have to do anything. You just have to swipe, and then the instructions are passed to your bank that this much amount has to be transferred to this XYZ. And then came the era of digital currency, which we are talking about is Bitcoins and so on and so forth, right? So this is how the monetary system has changed. The basic idea is to ensure that the exchange is proper. There is trust. If you are buying something of 100 rupees, you are getting something worth 100 rupees. Okay, so that is what it is. So now instrument of trust also has got boosted because of innovations, important innovations like telephone lines, credit card system, internet, mobile technologies, and all these technologies, innovation in technologies, have improved the convenience, speed, and efficiency of transactions while shrinking and sometimes virtually eliminating the distance between buyer and seller. Okay, so basically, these innovations will help you in performing your exchanges in efficient manner. Let's look at what innovations we are talking about. Technological advances we are talking about. So we are talking about digital. It starts with digital, that is computer. Okay. Then came network, where all the computers were interconnected with each other. Then came the communication system, where you used to communicate with each other over internet using Usenet, email, messaging, so on and so forth. Then came the era of web, where you can have your portal, give your information, e-commerce, enterprise. So your way of interacting with the world is getting strengthened with time. Then came the era of mobile, where you have all app, maps, snaps, everything are there. It was not only used for talking, it was used for everything. As I said, apps, maps, and snaps. Then came the era of social media, social networks, right? See, more the network, more stronger you are treated as. Then because of all these technological advancements, there are lots of data which gets generated, right? Now, this data which gets generated has got potential to potential to basically help you improve your business. So many methods like data analytics, machine learning, Internet of Things also came into picture. And after that, then security part came into play, like crypto. So data, it was felt that it is essential uh, to basically secure the data, and the best way to secure the data is through cryptography, so then came the concept of Bitcoin, blockchain, smart contract, Internet of money, Internet of value, all those things, so it started with computer, then connecting the computer, then enabling the communication, then exchanging, doing business on computer and through internet, then on mobile, then connecting with people worldwide on the basis of your similar interest areas, then generating lots of data, and then ensuring the data is secured, right? Now let's try to look at what are the challenges with the existing system. So when I say existing system, I means both banking and business. So banking is basically when it comes to money transaction, and business is any transaction, tangible, intangible, everything, your property, your personal data, your I'll be sharing a couple of examples as we move on. But of course, this entire concept started with financial domain, but then its application, as I said, financial domain to adopt blockchain, it will take some time because there are so many policy related things, whereas for other domain it's not that critical, and it is possible that it can be adopted in other verticals, other applications fast. So look at the trading in the current system. Now if you want to do a trade, one person gives something to other person, let's say money, okay? So that particular record is recorded in a bookkeeping system, which is also known as ledger, okay, where all the transactions which are done are maintained. Now this bookkeeping system is not transparent, it is very closed and it is kept isolated. What if the pages are torn? What if the building where these books are kept goes on fire? So everything is lost. Now we don't have anything to prove that how much you owe to somebody or somebody owes to you. All the data is gone. We have seen this buildings, corporate buildings and government buildings catching fire. In Bombay, a couple of years back, Bombay Mantralaya had fire, so all the documents which we had submitted for our proposals for new colleges or something, they said like everything is burnt. Okay, and that year, I think this is 4-5, no, not 4-5, 7-8 years back, so that year we had applied for some course, and we could not get because those files were all burned and we had to reapply or something like that. So you can look it into Google and find out it was a particular year where Mantralaya in Bombay got fire, and the documents, there was huge damage in the document, right? And to avoid such things, such critical things, we need a trusted third party who will ensure that the transactions are correct. Okay, I mean, like a judge, like a judge. Okay, I validate that this person A has given this much amount to person B. So like a judge, third party. Okay, now with the adoption of third party also, your problem does not end. Of course, your problem of this type, which I just mentioned, will be handled not fully, but to some extent. But this particular adopting third party has also got some problems. So let's see what all those problems are. So the first problem is like transaction delay. Okay. Today you want to transfer some money to your friend, and because of some verification process or something like that, your transaction will not be completed in time. because they can't complete the transaction without verifying it. So verification will take its own time. It cannot happen in zero time. It will take its own time. So there is a transaction delay. Okay, it can be if I want to send money from my account to somebody's account in Germany, it will not happen spontaneously. It will take some time to transfer, right? Then every transaction you have to pay some fees to the third party, that is your bank in this case, right? Though this amount is very negligible, very negligible, uh, but still the report says that JP Morgan Chase, Bank of America, Wells Fargo alone have earned more than 6 billion from ATM and overdraft fees in 2015. Of course, this is old, but then this is enough for us to understand that how much a bank can earn just through transactional fees. Okay, so we are trying to save that, because we feel that we are doing so much of transactions, and it will be appropriate if we go out of that loop. Third party requirement is not there. And third and most important problem with the issue with the current system is double spending. Now, double spending is a scenario which happens in the case of digital currency. Okay, now digital currency is nothing but a file, digital file, which says that this has got this much amount and it is being transferred from A to B. Okay, now this is just a software file which can be duplicated intentionally or unintentionally. Okay, can be intentional to make some fraud, or can be unintentional, maybe by mistake, copy paste problem kind of thing can happen, and which will end up in pushing more fund than actually the fund which is there in the bank. So suppose, for example, Peter has got $500 only. Okay, but because the particular digital file is copied 2 times in the accounting system, it will be shown that there are $900, which is unnecessarily inflating the showing that inflation in the particular economy, but it is like very damaging for the economy, right? And you will not be able to make out which one is original and which one is fraudulent. What is the counterfeit money and which is the original money? You will not be able to make out. So this is a very severe problem with digital currency only. Okay, and I told you why digital currency. It's possible because it's a digital file. Okay, and it can be by mistake, can be copied here and there. Okay, so this is again an issue with the current banking system. And most important, than bank may go, can just go bankrupt. Okay, it can face some kind of crisis. We are in India, we are seeing every day, especially with this government, this bank, cooperative banks, we are just watching it every day. Some or the other banks are like facing problem. Why are they facing problem? Have they violated some rules? Have they not followed the procedure? Have they gone out of board to give the loans or something like that? Or they have done some favors to somebody. Something like that has happened. May not be intentional. I'm not saying they have done with the intention of doing fraud. They must have done it in the interest of bank, thinking that it is in the interest of bank. They must have followed the short path, but must not have given them the same result. So policies, the moment you violate the policies, the results are not going to be the same. It is, the banks are going to crash, get bankrupt, and the people who have saved their money, presuming that their money in the banks are safe, they have to lose it. And every day, these days, every day we are seeing one of the other cooperative banks are facing problem, and then government has to come into play, and then our taxpayer monies have to be funded there. So it's loss from this side or that side. It's loss and burden over us only. Okay, so these are few problems with the current banking system which forced us to think that why not to do away with the banking system at all. So let's summarize the problem with the centralized banking system. Third party though, but it is a centralized. So first problem is like it has got centralized power. If it gets collapsed, everything is collapsed. It has got private ledger. It is not open to the public to see what is happening. Why? Where are they using your money when you are taking a loan? Or when you are doing your FD, when you're doing your FD, where is that money being used and what purpose they are using? Okay, so it's all closed. You just have blocked your money for 6 years and you assume that at the end of the 6 years you will get double in return or maybe whatever committed by the bank in return. But you actually don't know where the money is invested, whether that investment is going to give them the return to return you the returns. Okay, so this is very complicated. It looks very simple, but it is very, very complicated. Double spending, I have already explained you in detail now. Prone to hacks. So since it is all digital, computerized, it's prone to hack. So once it is hacked, so everything will go hayway. And it's very, very difficult to then restore things. So these are the problems. See, I'll just take you one step back once again. So earlier we used to have barter system where you used to exchange your products which you had, then you went to using banks for trusted transaction. Now banks also has got problem. So you are trying to see as a human, as an intelligent species, you're trying to find out where your money and where your transaction can be safe, secured, and you don't lose your money. It's after all your hard-earned money, you don't want to lose. Now, to avoid cash transaction, banks came into play. Okay, now with banks also we are seeing that there are lots of problems. So we are trying to find out some other solution, which is in the form of blockchain, right? Let's try to look at what are the issues with business transactions. Now, when I say business transaction, banks are part of it. Any business transaction where you want to exchange anything, it can be money, it can be anything. Okay, any business transaction where some sort of exchange of money, of anything is happening. So many business transactions remain inefficient, expensive, and vulnerable, suffering from following limitations. So I would just like to stress again, this is not specifically bank transaction, any transaction I'm talking about. So any business transaction, if suppose you are avoiding bank, then you are doing the business transaction with cash. Now cash has to be a local transaction and it cannot be done for big amount. It has to be relatively small amount. So scale is a problem with cash. Scale, then geography is a problem with cash. Time between transaction and settlement can be long, right? So if you are using bank, then time between transaction and settlement is long. You pay the check, it takes 2 days to get transferred to somebody's account. Duplication of effort and the need for third party validation and or the presence of intermediaries add to the efficiency. Now, to avoid everything, you will include third party or intermediaries. So that is kind of duplication of work, and it is also inefficient. We have just discussed it. There are also chances of fraud, cyber attacks, and simple mistakes to add on to the cost and complexity of doing business, and they expose all the participants in the network to the risk if the central system, such as bank, is compromised. I've just explained you this. Okay, if your central system, central server of the bank is hacked, then your network is hacked, and everybody who has got account in that particular bank is hacked and compromised. Now, if you use credit card, it looks very, very nice, but then it comes with a cost. It's not for free. There, whatever transaction you do, you need to pay some service charge. It is not it's not free service. Of course it's a good service, but it's not a free service. And most important, that half of the people of world don't have access to bank account. This is most important. We have to understand it, especially in context to India and also in abroad. I'll just tell you in a while. So the last point says that half of the people of world don't have access to bank account and have had to develop parallel payment system to conduct transaction. Either they intentionally don't want to make use of bank for transaction, or they don't have bank account. Like the people who are below poverty line, I mean, now the government has done it as a mission that every citizen should have an account, so that if government want to give them some support, some money under some scheme, so it should go directly to their account. So this is a mass mission, country level, national wide mission, but it is yet to get completed. We are still in a process of doing it. And this is not only in India, this is there across world. I had been to Germany. I mean, I have been regularly traveling to Germany, and I have observed that their people are very, very reluctant to use either credit card or maybe online transfer or something like that. They believe in cash transaction. Now, once you do cash transaction, you are untraceable, whom you have paid, how much you have paid, what for you have paid, there's no log of it. And people are not ready to change. Anyways, for them, I asked, because of my curiosity, I asked them, what is the reason why you don't want to make digital payment? They said, we don't want our every transaction to be known to the government. Okay, so that was the reason. Now, limitations of the existing system. So previously we had to trust the financial institutes and other third party with our money, not knowing if they are safe and secured as they claim. So as I just now told you that if your bank is hacked, okay, what way you have, to get back your money, instead of just filing a case, knocking at the door of court. Apart from that, you don't have any other way, but you keep your money, your hard-earned money in banks, just with hope and trust that it is safe there. If you keep it in house, you will not get any interest on it, right? When you keep in bank, you get some interest. So you have that particular thing in mind, that instead of keeping at home, if you keep at bank, you will get some interest. And also your home is also prone to theft, burglaries, all those things, so it's better to keep it at bank. That is what is our assumption, that is what is our thought process, but not necessarily that is true always. You have seen a bank, especially cooperative banks, where a set of people who open it, or one or two person who open it, they say that although you will get so much of interest, more than SBI and all, and people get tempted and trapped, and they save their all money post retirement to that bank, and then suddenly after 1 year you don't find bank anywhere. So it's very, very essential to understand such entities are there, and we have to be careful. So the next point is the transactions in the deferred database takes time, cost money, or transaction charges, vulnerable to hacking, and can be error prone due to human intervention. So same point. So the transactions, when you use bank, it's going to take time, it will cost you something, it is prone to hacking, and error prone also, because finally you are entering your data, instead of 1,000 rupees, you can enter 100. You might miss pressing 10, so that will reflect a wrong. So error prone is also there. So we are subjected to all such difficulties and hassles, but with the emergence of blockchain, all these issues can be resolved in a safe, secured, and effective manner by revolutionizing the way of managing data and database. So what are we trying to do? We are trying to change the total way in which we are storing our data and databases, managing our databases. Let's see how we do it. But before that, let's look at why do we need it, So we need it because the transaction volumes worldwide are growing exponentially. due to the growth of e-commerce, online banking, in-app purchase, and increasing mobility of people around the world. So lots of online transactions are being happening through multiple sources. It has grown exponential, right? And then in this scenario, if any of the third party system collapses, your entire network will come down. So there's an urgent need of some parallel system which can ensure that your data or transaction is secured, and come what may, it will not be lost. Whatever happens, it will not be lost, which will magnify the complexities, vulnerabilities, inefficiencies, and cost of current transaction system. So because of all these things, your load on the existing system will increase and will make them more complex, more vulnerable, more inefficient, and increase the cost of transactions also, because they'll have to do more transactions, they will have to do more work. So they might well increase the rates, and it is a warning that with rise of Internet of Things, the transaction volumes will explode. We have autonomous objects, like you have refrigerator that buys grocery when supplies are running low. You have autonomous car which uh, automatically goes to petrol pump and fuel itself. So with such things where humans are not interacting, your machines are interacting, the transactions are going to grow many fold, and in that case you can't afford the collapse. You can't afford the collapse, because it will be very difficult to trace it out, whether it is intentional, whether it is for anti-social element, whether it is anti-national activity, you will not be able to make out. So it is very essential that we have some robust system. So to address these challenges and others few more, the world needs a transaction payment network, okay, that are fast. First thing is fast. It has to be quick. That provides mechanism that establishes trust. So it has to be fast. It has to be trustworthy. Requires no specialized equipment. So it should not add overburden to install this, remove that, have this much memory. All those things should not be there. There should not be overhead. No chargebacks or monthly payments. Monthly fees. There should not be additional charge for it. Provides a collective bookkeeping solution for ensuring transparency and trust. So basically, in this scenario where everything is growing exponential, online transactions are growing exponentially, you need a payment networks and database system which is fast and can be trusted. No specialized equipment is needed, no chargebacks. I mean, you need not pay anything, and there is a collective bookkeeping solution, right? So that is what is the need for blockchain. Now let's look at the history of blockchain. It has not come suddenly. There are so many people who have been working on it day in and day night since so many years. It's a different story that we came to know about it only in 2008, 2009, right? So I mean, it's very essential that we appreciate the effort of people which has gone for so many years. As per the record, since 1980s. So it's almost 30 years, people have been working on this technology, which is now showing some result, some shape, some structure to all of us, right? So let's look at it before we go ahead and dive into the blockchain, which is very interesting. So all this theoretical part might have made you think that where is blockchain? It's coming up. Don't worry, it's coming up. And it is going to be very interesting again. But then I am sure whatever I have told you is very essential for you to understand and appreciate the very being of blockchain. Right? If you do not know why, see, every technology has a purpose to be there, it's a need based. It's a need based, not just because somebody is sitting idle and want to do something, some cryptography, and came up with some technology and people will accept it. There has to be demand supply, there has to be problem and solution, and then only you get appreciation. So it's very essential, and that's the reason I have kept it intentionally, though it takes some time, but it's very essential that we appreciate all these. So it started all in 1980s till 1990s, where the movement was from cash to digital. You know, so people were like, let's do away with cash transaction. Let's go on digital, right? So 1980s till 90s, it was all the era of trying from movement from cash to digital. So first product which came, in fact, DigiCash is a company, and DigiCash is also the name of the first digital currency also, right? So this company was set up by David Chaum in 1991, and the idea was to make the transaction with digital cash, digital currency, okay? And of course, at the same time, the transaction should be made anonymous, right? Now, David Chaum is a person who had invested. In fact, he is a mathematician, cryptographer, working in a very good company. And he, since 1980s, he was working on various algorithm, cryptographic algorithm, like blind signature, anonymous network, secret sharing, all those typical things which are basically the foundation of blockchain. So he was working for all 10 years before he went ahead and launched a company called Busy Cash. And he is a US American, uh, and set up a company, but then company didn't do well, and he had to shut it off in 2001, I guess. And the reason behind this was Deutsche Bank had adopted this. There is one more bank, I am not recalling the name, that also had adopted. But then the problem was this was much ahead of its time. Those days, the internet had just come. People had not started e-commerce. Online banking was just coming up, you know. So this particular concept was much ahead of its time, and there's the reason for its closure, you know. But it made a foundation for Bitcoin. In 1992, there are a group of people from different walk of life. They came together, and then they made a manifesto which they called Cyberpunk's Manifesto. And they tried to highlight that privacy is not secrecy, and they were like the propagator of anonymity. You know, they said all the transactions should be made anonymous, and whatever we have to do to make the transaction anonymous, we should do it. I'm not saying right or wrong, but this was the fact which I'm putting it before you. You know, 1997, there was a hash cash which was given as a proof of work system by Adam Back in 1997. And as I said, it's a proof of work system which used hash cryptography and allows communication. So the foundation, I mean, see, one after the others, everything is building on. You know, nothing came overnight. It's lot many years of hard work which has gone into developing the concept, developing the protocols, developing the technology, you know, and then putting it together all together. Then B money was never implemented. It's an article which was published by Wei Dai in 1998, and it was mainly on anonymous distributed electronic cash system. Of course, the idea was very good, but it never got implemented. So as an idea, it just pushed on, but of course, as I said, it was never implemented. 2005 Bitgold was proposed by Nick Szabo, and a very important concept of timestamp, hash cache, and cryptographic puzzles were used, which again was a foundation for Bitcoin. And then 2008, there was an article published by Satoshi Nakamoto, which highlighted the concept of Bitcoin. Now, in this paper, it was all about Bitcoin. But then here, for the first time, we heard about the term blockchain. You know, people were working on it so many years, similar concept, but it came into the light. The concept, the technology of blockchain came into light when Satoshi Nakamoto published his paper on Bitcoin. So he said, and Satoshi Nakamoto is We don't know whether he's a single person or a group of people. But then the paper was published in this name, so we have to accept it the way it is. The paper was basically about Bitcoin, a peer-to-peer electronic cash system. But in this paper, he has spoken about the foundation fabric, which is a blockchain, okay, technology. And two more important people who have played a very, very vital role in blockchain technology are Haber and W. Scott. And of course, they never called it as a blockchain, but then they have worked a lot in finding out how a timestamp can be put up to a digital signature. So their work was always around putting a timestamp to digital document. Okay, and this is exactly what blockchain is has adopted, right? So this is how the technology has come. I have just mentioned few names. There are so many people who have worked towards it because it was interesting. It is not, again, before we go ahead, I would just like to emphasize on the fact that this is not a technology in isolation. It uses maths, it uses cryptography, it uses so many things, database concepts, transaction concepts, so many things it uses. And then whatever is served to you is called blockchain. And on blockchain is technology. On blockchain, you can have many applications, many protocols, right? Which I'll be telling you so that it will give you a fair idea of all the layers also, right? So now till here, your blockchain was known, as I just told you, Haber and Scott, they worked on first blockchain. So they were working since so many years, 1991 to 2008. And then only in 2009, when Satoshi Nakamoto came up with his white paper, we got introduced to the term blockchain, right? And then all the transactions of blockchain took like couple of years. So we can divide the complete life cycle into three phases. The phase one, that is blockchain one, is about Bitcoin emergence, right? Where we talk about the transactions which can happen using Bitcoin, how the transactions can be done, how it will be beneficial, all those things around evolution. The phase two can be considered as a Ethereum development, which is about contracts, smart contracts, right? And phase three can be considered as future of blockchain, which is about application, which is endless. We all can keep on trying, keep on thinking of good applications, and keep on serving the data world. So the entire journey can be divided into three phases: blockchain one, which is evolution, emergence; blockchain two, which is about contract, and blockchain 3, which is about applications. Now let me, before we dive into that, let me just define it for you. Define it from all the perspectives, so that we are not looking at blockchain right from front. We are looking at it from various perspectives. How I define blockchain, how will you define being in FinTech a blockchain? How will a social person will define? So from all the perspective, let's try to define it. So how it is there on the Wikipedia? So as it is from Wikipedia, a blockchain is a continuously growing list of record called blocks, which are linked and securely using cryptography. Okay, so as we can understand from the name itself, it's a chain of block which is continuously growing with the records and are linked to each other cryptographically. Okay, so this is what Wikipedia has to tell. We can always define it as a new type of database and transaction management system. Okay, so there's no doubt, we know that blockchain is about recording the data in a secure fashion, about recording the transaction in a secure fashion, so that nobody can alter, nobody can change, right? So blockchain is an open, decentralized, so no central control, distributed database. It is implemented on peer-to-peer network. ledger that can be, so open, decentralized, distributed ledger that can record transaction between two parties efficiently, track the asset in the business network, and maintain a continuously growing list of records called block in a verifiable and permanent way. Very, very important. So what blockchain does, it records your transaction between basically two parties. It also tracks your network, track your asset, maintain the continuously growing records, and it is verifiable. How it is verifiable, I'll tell you with an example. And if time permits, I'll show you some demonstration also, which will make things much clearer. So third point, which says that maintain a continuously growing list of records called blocks and in a verifiable and permanent way. So what are we trying to keep it secured is your asset. Okay. So what you are trying to store in your database, which is a blockchain, is your asset. Now, asset can be tangible, like you can have the details of your house, can store the details of your car, cash, land, anything which is tangible, or something like which is intangible, like intellectual property, patents, copyright, branding, your personal data, right? So everything, government data, so everything which is maybe intangible or tangible can be kept in a secured way in blockchain. Virtually anything of value can be tracked and traded on blockchain network, reducing risk and cutting cost for all involved, right? Now let's look at the definition, as I told you, from different perspective. Wikipedia we have already seen. So technical, how blockchain will be defined by a technical set of people. So technical people will say that blockchain is nothing but a linked list, which is built with hash pointers instead of regular pointers. Now, since we have all management faculty members here, I presume that. So basically, when two blocks are there, you connect them with the help of pointers, just for now you understand, with the help of pointers. And here we have different kind of specialized pointers which are known as hash pointers, right? So a pointer, a points, so one block here, one block there, and it points to, so you know that this, after this block you have this block to come, right? So how a socio-political, economic, semi-technical libertarian will define this? So they will define a blockchain as an open, borderless, decentralized, public, trustless, permissionless, immutable record of transaction. Okay, so everybody has got one adjective to give here, open, available to everybody, borderless, no boundaries, decentralized, no central control, public, that is available to everybody, trustless, it will not collapse because of breach of trust by anybody. Permissionless, it can be permissioned also, it can be permissionless also, but then as per their definition, it is permissionless. So you need no permission to enter there. Immutable means you can't change. Okay, so this is a definition by socio-political, economic, semi-technical, libertarian people. Okay, group of people. Now, how financial accounting people define it? So as per them, blockchain is a public distributed ledger of peer-to-peer transactions. Now, all these terms which are appearing confusing to you, like decentralized, peer-to-peer, public, all those things will be sorted out in just some time. Before I leave, I'll ensure that I am not leaving you with any doubts. So this is all about definition. Just a quick confirmation. Am I audible, clear? Hello? Any one of you can unmute and just confirm me?
Ma'am, you're audible.
Okay,
Yes,
thank you.
Yes, ma'am.
You're audible, ma'am.
Thank you so much. So let's start. So I have set the context. Now let's start understanding the blockchain, right? So what is the basic ingredient of blockchain? We know, block, right? So what for we have the block? What is the purpose? To store the data. Now let's assume the data here in, hello? Hello? Is there anything for me?
No, ma'am. No, sorry for that.
Okay, thank you. So as I said, so the building block of blockchain is a block, right? And what we are expecting block to store is the data. Basically, we want to store our data in a secured way. So data is the first element which will go in the block. And then you will have previous hash. Now, for now, you just understand there's a link. Previous hash is a link which will connect it to the previous block, right? And then using the data and the previous hash, a particular hash of this block will be created, right? Now, this hash will be unique, which works as an identity for this particular block, right? So you can think of the hash for this block as a fingerprint for this block. This is as unique as a fingerprint of a human being, right? So I'll just repeat, your block will have data, your block will have previous hash, and using these two elements, your current hash of this particular block will be calculated. So first block is always known as Genesis block, because this is not going to change ever. You know, how may ever long your blockchain may grow, but the first block will always remain same, you know, because it does not have any previous. You can see the previous hash is all zeros, and the hash for this particular block is this one, right? Which is again a unique identification for Genesis block. Then you add a next block, which will again have data. You will have a previous hash, which will be taken from the previous block. And then using the data and the previous hash, the hash for this will be calculated. Likewise, you will have the third hash, which again will have data, and it will be linked to the previous block with the help of previous hash. And using data and previous hash, your hash for this particular block will be calculated. So you can easily, yes.
Your screen is not visible, ma'am.
My screen is not visible.
Yeah.
But there is absolutely no problem from my end.
Ma'am, it is visible. The participants has to pin it.
Okay. Okay. Thank you.
Pin the presentation, ma'am. Pin the presentation in Neha ma'am's name.
Okay, ma'am.
Thank you. Okay, so now we can easily define, I mean, till now I have been talking that blocks are cryptographically linked. Now you can see that how the blocks are cryptographically linked. Now, previous hash is nothing but a hash number. What is hash? We will be discussing this in detail, you know. So for now, you just understand that blocks are cryptographically linked with the help of previous hash of the previous block, right? So this is a basic concept of blockchain, where you have blocks which has data, which has got previous hash, and it has got the hash of its own, which is unique, right? Now moving ahead and trying to look at the important features of blockchain, right? So hash cryptography is the most important, and we will talk about this in a moment. Then immutable ledger, then distributed P2P network, mining, consensus protocol. So these are 5 important features, characteristic, attribute, whatever you want to call it, of blockchain, right? So let's start with hash algorithm. So hash algorithm which is used, there are many hash algorithms, right? The popular hash algorithm which is being used with the blockchain is SHA-256 hash, right? SHA stands for secure hash algorithm. And 256 because it takes 256 bits in the memory, right? Now SHA-512 hash algorithm is also there because it takes 512 bits in the memory, right? So very popular one is SHA-256. You can read it also, Google it out for yourself, but I'll leave you with pretty good understanding here. So blockchain usually use SHA hash algorithm to cryptographically link with the previous block and create its own unique hash also, right? Now, let's try to understand what is the purpose of SHA-256 hash, right? So, every individual has got a unique fingerprint, right? Nobody can deny this. The population will have their own fingerprint, whereas in the population, your fingerprint will always be unique. There is rarest chance that two people can have same fingerprint, rarest chance. And the study says that it is 1 in 60 billion. So it's very, very rare, right? It is so rare that you can ignore this, right? So as fingerprint acts as a unique identification for us, human being, likewise, this SHA hash will act as a unique identification for your block, right? Now, how SHA hash is calculated, I mean, how I will not take you, how it is unique, I'll tell you, right? So as I just now told you that every individual is uniquely identified through its fingerprint. Likewise, our endeavor is to ensure that every document should be uniquely identified. Now here we don't have fingerprint. What we are trying to have is hash, hash, which is a number. So we are trying to associate a number, unique number, which will identify your document uniquely. Now, any number, sequential number, random number, if you assign, it's very easy to hack it. It's very easy to tamper with it. But if you use some algorithm, like a strong algorithm like SHA-256 hash algorithm, then the number which is generated, it cannot be tampered, right? Why it cannot be tampered? I'll show you. So the endeavor is to create a unique identification for each document, which is a hash number, right? So it looks like this only, exactly like this, alphanumeric. Now this SHA-256 hash was first used by NSA, which is National Security Agency of United States of America. And as I just told you, it takes 256 bits in memory and 64 characters, and it is alphanumeric. So it takes from 0 to 9 and A to F. Okay. So you can see it's not only 0 to 9, it has got alphabets also in between, in caps and small both. Here we can see only in small, but you can have in caps and small to increase your number range, right? So SHA basically takes 256 bits in the memory and represented by 64 characters, right? Every character takes 4 bits, and that's how it makes 256 bits. And whatever be your document, howsoever big, howsoever small, it is going to take only 64 characters. That is 256. If you do not have anything in your document and you mine it, okay, block, not document, in block, and you mine it, still you will have a hash of 64 characters. If you put your name as a data, still it will have 64 characters. If you have a complete chapter as a data, still it will convert it into 64 character hash. So whatever be the size of and type of, if it is photo, still it will be converted into 64 characters hash, right? So whatever be the size and type of your document or data, it will be converted into fixed size of hash number, right? So just to make it simple, as you have your fingerprint as a unique identifier, every document which you want to have in your block, every block with the data will have a unique number, which is absolutely unique as that of your fingerprint, right? So SHA-256 creates hash for all types of digital documents, as I just now told you. It can be text, PDF, video, audio, executable, or operating system even. You can have any data. Data can be anything in your block, as small as like a text of one paragraph, 200 words, or it can be a complete book, it can be executable, it can be operating system. But whatever be your data, it will be converted to fixed size of hash number, right? alphanumeric number, right? Now important thing, this slide tells you very, very important feature of hash algorithm. It is one way. Now, what do we understand by one way is, for every document which is there in the block, you can create a hash, right? You can create a unique number associated with the document, right? But from that unique number, you can't create the document back. So it is only one way. For every document, you can have a unique number, but unique number cannot be used to create the document back. So that is one way. It is deterministic. That means if you have the same document, you will have the same unique number generated. If you make a slightest of the change, your number will be changed totally, right? So as I just told you, same hash will be generated each time for particular document. Fast computation, of course, it does not take time. It is a fast computation. Hash algorithms are fast in computation. Avalanche effect, it is most important. As I just told you, if you make a slightest of change in your document in the block, your hash number will not change slightly. It will change entirely. Okay, I will show you, as I told you, as I have promised you, I will show you at least this part of it. So small change in the document will change the hash completely, right? And the first one, it must withstand the collision. Now, there is a possibility that rarest of rarest case, two people can have same identification number, as we just now I told you, like rare of rarest case, 1 in 60 million can have same fingerprint, right? Now in that case, if the same hash is generated for two documents, because of collision, because of as a rare situation, then we should be able to accommodate it. But at the same time, you should avoid fraudulently created similar document. Now, if suppose this document has been created with this, associated with this hash number, which is unique. Now, there should not be any way in which you create some other document which fraudulently generate the same unique identifier. Now, to handle such situation, for it not to happen, we have blockchain, right? So hash algorithm helps you in creating cryptographic numbers, right? Very efficient, unique numbers. But to avoid that numbers are not being generated, duplicate numbers are not being generated fraudulently, we have blockchain system, the complete system. And hash algorithm plays a very, very vital role in that, right? Immutable ledger. The second point, second feature of your blockchain is immutable ledger. Now, ledger, we all know, ledger is a place where we keep a bookkeeping, record keeping, anything, right? If that particular ledger cannot be changed, cannot be mutated, it becomes immutable. So with blockchain, we try to find out a place for data which cannot be changed. You know, we know it is as per the definition. So our understanding on blockchain is like it's a chain, it's a block which are linked together cryptographically, right? Our understanding is this. So there is a chain which is created because of keeping the previous hash in that particular block. So we know this. Blocks are there and they are chained with the help of cryptographic link, which is nothing but the previous hash, right? Now coming back to taking our understanding of blockchain to understand immutable ledgers. So suppose you have money, you know, and with this money you buy a house. Okay. Now just by paying money, is your house yours? Do you own this house? No, certainly not, right? So for that you have to sign a deed. Sign a deed with maybe the builder who has built that house, maybe the previous owner who owned that house before you. So there is a deed which has to be signed. Now this deed also has got no meaning unless until you go to the government authority and register your property in front of him and get it entered into their records. Okay. So till that point, your property is not yours. Now, that is the only way in which you can prove that this property is yours. This document, registration document, is the only way to prove that the property is yours. Now, in traditional ledger, what you do? Usually, you either maintain it on computer, if it is a digital things are available, or usually you maintain it in a bookkeeping system. Now, when you maintain the record of your property in bookkeeping system, it is possible that somebody can hack it. You know, somebody can steal your property or can do some mischief with that. You know, somebody is eyeing on your property and can do some mischief. Can give some bribe to the government officials and maybe can make some changes. Maybe can tear the page and stick it somewhere else, or can tear the page and throw it. So once the document is not there, once this ledger is not there, or if suppose there's no hacking, if the building where the document is kept catches fire, your document is all gone. Okay. So what I want to tell you, whether somebody does it intentionally or some natural calamity happens and the document is gone, there is no other way to prove that the house belongs to you, and then the house does not belong to you. Right? So here, to our rescue comes the blockchain. Right? Let's see. So blockchain, suppose this blockchain is a chain which stores the data of all the properties in our country, for example, in our country, right? So it can, and maybe in your state-wise, you can maintain, the government can decide to maintain it state-wise, right? So it's a blockchain where all the property details of that particular state has been maintained, right? Now, your record comes here. Okay. When you register, your position is here. And suppose somebody tries to hack this, or somebody tries to want to change your name with his name, right? But by then what will happen? Some more nodes will get added to the chain, you know. And now when this person tries to hack your particular details or change your name with his name, convert the property in his name, so this becomes, this hash of this particular block will change automatically, because the moment you change a single digit, the hash also changes, you know. And the moment the change is done, this becomes, this cut off from the chain, and the remaining nodes also from the chain is disconnected. Right? So this cannot go unnotified. Any change in this record, come what may, any change in this record, which is your record, if it is done, it cannot go unnoticed, because the moment anybody does a change, performs a change here, the entire chain is unchained from the main blockchain. Now the person has to be really smart and fast to make a change here and in all the nodes quickly, which is very, very difficult. You know, you will not have limited nodes in your network. You will have unlimited nodes in your network. And to make changes in all the nodes, it's highly, highly difficult, you know. And here I am just telling you one blockchain. In peer-to-peer network, this complexity will be multifold increased, you know, it will be increased in multifold way. But here also you can just understand and sense that removing a page from the physical document and removing and changing the data here is how much difficult. And it cannot go unnoticed, as I told you. It cannot go unnoticed. Somebody will surely catch you. And blockchain is not on like on one computer, it is on peer-to-peer network. In that scenario, it is highly impossible to make any such changes. We will see it in some time. So I have told you the difficulty at level one, difficulty at level two, we will be discussing. Now, why the property document should be there on blockchain? This is just to give you an idea, like not only FinTech, there are many applications. And why property? Because directly, indirectly, it is related to finance, number one. Second, like if you can just see, this is till January 2018, you can see on an average every month, 100,000 registrations are done in the United Kingdom. That means every day around more than 3,000 registrations are done. And this is not of small property we are talking. We are talking of property which is more than 40,000 pounds. So lots of financial transactions which requires a blockchain for its security. Because one loss is a major loss. Any loss is a major loss, right? So a good application for blockchain is this also. Now moving to distributed P2P network. There are many types of network we all know. First is centralized, where every control is there on the central node. Then we have distributed, decentralized, centralized and decentralized. So centralized, you will have one central node where all the control will be there. Decentralized will have a small networks and which in turn are connected. So decentralized will have the control divided. Okay, but below that particular divided control, you will have a controlled network. That is decentralized. Now distributed is like everybody has got equal control. Peer-to-peer has got, everybody has got equal control. Everybody is contributed towards fall and rise of the network, right? Let's look at it. Now distributed peer-to-peer network will have many nodes as usual. Okay, here I'm just showing you 6 nodes on your screen. All are connected to each other. The idea is to ensure that all the nodes are connected to each other. If some are not, it's okay, but then most of the nodes are connected to each other. And every node has got blockchain, one copy of blockchain, right? Now, if you add your property, for example, we will take up the previous this thing only, your property here. So it will get your peer-to-peer network has got its own way to update itself, and it will get updated throughout the network everywhere, right? You add your property details are replicated on all other nodes everywhere. Okay. Now, if suppose, and it keeps on growing, right? Likewise, it keeps on growing. There are many other nodes which are continuously getting added to your blockchain, right? But remember that on peer-to-peer network, every node will have a copy of particular blockchain at their place, right? Now, if suppose a hacker tries to hack your property, right? Wants to change your name with his name. So as we discussed, this will cut off this particular node from the chain, and in turn, the remaining nodes will also get cut off from the chain, right? So the entire thing is now not in the blockchain of that particular node, right? If the hacker is very smart, he will do it very fast, and then he will try to update all the other nodes also, which is highly impossible, and of course, if he wants to do, he has to do it very quickly, which is, again, I'm just saying it is impossible. It's not possible in this in this 6 nodes only. Forget about when in actual scenario there are hundreds and thousands of nodes connected, in P2P network, right? So now this particular node has got only this much blockchain, and network has got its own mechanism to keep on checking, even if the blocks are not added, they will keep on verifying whether my data is same as that of your data or not. Now, in the course of verifying, they will realize that these three nodes have got same data, but on this node, the data is not same. Okay. And they will force correct this particular node, and the original data will get restored. Okay. So this is how it will work, and it will safeguard itself. Now coming to mining, this is the heart of whatever I have explained to you. This is heart of it, and it is very essential that you understand this process very carefully. If you understand this process carefully, then you understand the complete philosophy of blockchain, right? So I have told you hash algorithm, I have told you this immutable ledger, I have told you peer-to-peer network. Now we are on mining. I'm not saying these are not important, but then the heart of blockchain depends on your understanding here, what happens actually. Now my question to you is, see, what we have seen till now is like, you create a block will hold the data, right? And you have to ensure that the block is added to the chain. Now, when you create a block, that means you are adding a hash to it. Once the hash is created for a block, your block is ready, right? But it does not mean that when your block is ready with its own hash, it can get added to the network. To get added to the network, you have to compete, and this is the process of competing. So it's not just creating a hash, it's about getting added to the network also. So let me, whatever I have told you, I'm going to tell you with the figures also, with the pictures on your screen also, which will make you understand.
Excuse me, ma'am.
Yes.
Sorry for the interruption, ma'am. Ma'am, actually, some people are facing issue to pin your presentation. So can you please stop sharing and reshare your presentation?
I will, yes.
Thank you so much, ma'am.
I'll reshare now. Huh? Can you see my screen now?
Yes, ma'am. Now it's visible.
you can get a quick confirmation from participants also. They should not be facing any problem.
Yes, ma'am. I'm a part of participants only. Yeah.
Okay.
Thank
Okay.
you so much, ma'am. Sorry for the interruption.
No. I mean, it's of no use if you can't see it.
Exactly. Thank you, ma'am.
You want me to repeat anything? Hello?
No, ma'am.
That's okay, no?
Yes, ma'am.
Okay. Yeah. Thank you. Okay. So we were on mining and I told you like this is important and good that you stopped me at right place. This is really important. So suppose this is your block, of course, the pictorial representation shows it in the form of block, right? And this block is chained from both the ends. So what this block holds, first is block number, right? And then is the data, right? Now the data here is like not single transaction. The data can be multiple transactions also. Can be anything, in fact. Here we are showing transactions. It can be anything tangible, intangible, as I told you right from beginning. Here and as far as transactions are concerned, it need not keep only one transaction. It can have n number of transactions bundled together. So here we have Kirill giving 500 head coins to Headlin, Kirill giving 100 head coins to eBay, Headlin giving 70 head coins to Joe. So some transactions which are being kept here. Then you have previous hash, which comes from your previous block. That is also static because previous block already has its hash number, unique number. So that comes from here. And then on the basis of all these three, you calculate the hash for this particular block. Now, can I ask you, one of you here, what is the problem here? So as I have been telling you right from beginning that this hash, which has been created for block number 3, which is shown at the bottom of your screen, is the unique identification for this block. But now my question is, what is the problem here? Or if at all there is any problem, or it is perfect as per our understanding till now. I mean, one response from the participant should be okay. One of you can unmute and respond. Or it looks okay. If it looks okay, then also you can say that it looks okay. It is as per our understanding till now. So it has got all the ingredient and the hash which we have created is perfect. So if you feel so, that also you can say. I mean, see, this is not a test.
Excuse me, ma'am. There is a response after Ranpreet Kaur in the chat box. He's saying that it needs approval.
Yes, ma'am.
It needs approval. It needs approval. Okay. And any other, I can't see that, that's the reason I'm asking. I am unable to see because my full screen is like my presentation only. Okay. So I can't see it.
Yes, ma'am. It's in the approval, ma'am, already.
Ma'am, I have a question in that.
Yeah, go ahead.
Because you told that in data we have a number of transactions. So every time we are going to have a new transaction, then every time a hash is going to change, right? Now this hash, if this hash is going to change every time, and this hash is linked with the next block, so there will be a rapid change in the hash for each and every transaction. So that could be an issue.
No. Thanks for trying at least. See, yeah, few things which we have to understand very clearly. First thing is your block, right? The basic objective is to create a block. Now, how do we create a block? When you have some data which you want it to be saved, preserved, you wish to create a block. Now, every block, when you have a data, then you will try to create a block. So block will have a block number, maybe anything. Here it is 3. And then whatever data you want to store, like till now you have 3 transactions and you want these 3 transactions to go into a blockchain. So these 3 transactions till that point of time where this block is being created, right? And then we take previous hash from your previous block, and then using all these 3, you create this hash. So this becomes three inputs for this hash, which is the hash for this block to be created. Is that okay? Is this okay? Till here it is okay. Now, now the question which somebody asked right now is like, what if more transactions happen? Okay, so any transactions which happen after this will go into next block. So we try to take all the transactions which happened till that particular point of time, and we bundle it into one block and then try to process it. You know, after this, if anything happens, it will go into new block and it will be added to the chain, right? So now my main endeavor is to make you understand that this block is static. This block number is static. It will not change. It is the serial number of the block. This data is static. This will not change. This previous hash is also static because it is the identity, unique identity of the previous hash. Now with these 3 static values, how can you come with a hash which cannot be penetrated, which is not vulnerable? Because you know you have the static information which you are using to create a hash, and you are saying that the hash is a unique number and which cannot be tampered, which cannot be mutated. Understand this. There has to be one element which is dynamic and not known. Unless and until you have a feature which is not known here, then this is known to everybody. Anybody can come into and hack your chain. You know, so here you need something which is not static. Now, what is that something? Is this element which is known as nonce. Nonce is number used only once. So as the name suggests, that this is any number, just a number, which is used once. Now, with this 4th element, which is dynamic in nature, you use now 4 element to calculate your hash. Right? So there is no approver here. There is no approver here. You have 4 elements which will help you create the hash. Now, most important is that once you create a hash, this does not, that means once you have created hash, that means your block is ready. You have correct data. You have everything correct. You have created the unique identifier also. So your block is ready to be uploaded on the chain. Now, there are so many. See, just presume a network where thousands of nodes are there, thousands of transactions are happening, and thousands of miners must be trying to mine a block and trying to upload it on the net, on the network, right? So whose will be uploaded at that particular point of time? And all are fair transaction, no fraudulent transactions. Now here comes the concept of puzzle, you know, the complications. We have been talking that it's a puzzle which is given. You need to solve the puzzle and then you can add your block to the chain or to the network, right? So till here I have told you that there are 4 elements which plays very critical role in identifying the hash or in generating the hash for this particular block. Now this hash becomes the unique identifier for the block. Now the second part, once you are done with this, second part is you have to upload this on the network. So what plays an important role in uploading is what I'm going to explain you right now. So be attentive. So just notice there's no nonce, right? You have some hash. Be careful on your screen. You can see that hash starts with 82B5 and ends with 57, right? When you add a nonce 19, everything changes. When you add a nonce 20, again everything changes. The entire hash changes. So you can keep on using nonce to get the hash. This is what I am trying to tell you. You can use multiple nonce, different nonce every time to get the hash, right? Now, why you have to use different nonce? You can use any number and you can create a unique hash. Why is there a need of using different nonce, which is creating altogether different hash for the particular block? Can you see that? With every nonce, your hash is getting changed. Now I'll explain you why is the need for trying out with multiple nonce. Why are we trying out with multiple nonce for the same block number 3? Why are we doing that? So first and the basic thing, okay? Hash is a number, okay? We all agree hash is a number. It's an alphanumeric number. You can see 0 to 1 and A to F, right? And this is 64 characters. Now this is a number, it represents some number, some huge number, and you have a decimal equivalent of it also. Of course, it will be much lengthier, longer number because it has only 10 digits, 0 to 9, right? So if you represent the hexadecimal in decimal format, it will be longer than. If you represent the same hexadecimal number in binary format, it will still longer, right? So we want to save this space, so we have used hexadecimal numeric format. So here is another hexadecimal number with its equivalent decimal representation. Third one, third hexadecimal number with its equivalent decimal, right? Now leading zeros here just says that it's a smaller number than the above number, and here you have more leading zeros, that means it is still smaller than the above number, right? Now presume that this is a hash space, right? The purple color hash space, where you have all the possible hash for the 64 characters, 256 bits, which can be represented in 256. All the possible numbers are there, which can be put up in this space. It starts from your left bottom corner, right? Left bottom corner with all zeros, 64 zeros, and it ends with a top right corner with all 64 Fs, right? And in between you have all the numbers, right? Just a quick confirmation, is the slide visible now?
Yes, ma'am.
Okay, perfect. Thank you. So, this is what is your hash space, right? With the smallest, all 64 zeros on left bottom and all Fs on right top, right? Now, these numbers which are there on the left side of your screen fall somewhere tentatively here on your screen, right? This is all big numbers. So let's assume that it is on the top of your screen. This is with some zeros, so it falls somewhere in between. And this is with more zeros, so it falls somewhere at the bottom of your screen, right? So just tentatively. So you have to understand that there's a number which is at the top of your landscape, hash landscape, and or maybe at the bottom of your hash landscape, right? Now, there is a target set, right? Now there is a target set. The target can be anything, any random target. It has got no economical relevance. It has got no cryptographical relevance. It has got no political relevance. It is just a target set as a maybe as a benchmarking or as a hurdle, creating a hurdle. So the target says that whatever hash you generate for your block should be below this particular target, right? So the first hash disqualifies because the number which has been generated is above the target. The second hash is also disqualified because the number generated is above the target. Third one falls below the target and it can be considered, right? So you can have a, I mean, like for an example, you can have a target like you should have a hash with leading 4 zeros. That can be a target. Now leading 4 zeros, that means when you add leading zeros to your numbers, you can clearly see the number is small. On your screen, you can see when you add, the more number of zeros you add on your hexadecimal number, the number becomes small, right? So here as a target, you can say that leading 4 zeros can be a target. So anything below that can be considered as a hash, can pass the exam, and that block is now eligible to get added to the particular network, right? Now let me take you to this example.
Hello, ma'am.
Yes.
If 2 or 3 hash values will be there in below the target level, then which we have to choose?
Which one? 1 second. Should I go back to this?
Yeah, here it's of the target level. Below the target level,
Mm-hmm.
if we have 2 or 3 hash values, smallest values.
No. See, the moment you get, I am coming to that. Just a moment. Give me 1 minute to complete this. You will get your answer. Okay.
Okay.
Okay. So you start with random number. As I told you, there is no reason. You have to keep on trying. So that's the reason they say that a miner should have good computational power, lots of machines, good electricity connection. So and it is computationally very high, so heavy. In fact, high, I should not say, it should be very heavy. So it started with 23. So once again, I'll tell you, the block number is static, data is static, previous hash is static. Only nonce which we are changing. Now why are we changing? Because we have a target to meet. So with 23, you start with 23, you get a hash which is much beyond. Then you change the number 22. Now this is not sequentially. That means you start from 1 as a nonce and you keep on trying. The hash which you will get can be anywhere in the space. There is no sequence. It does not totally depend on the sequence of nonce. You can't start trying with 1, 2, 3, 4 and keep on trying, right? So the bigger number can give you smaller hash or the vice versa, right? So you have to just keep on trying, right? Keep on trying till the time you get a nonce which is below the target. And the moment you get a nonce which is below the target, you stop it. You don't again try, because it requires a computational power. It requires electricity. It requires manpower, right? So the moment you get a nonce, that means you have got a golden hash and you stop there. That means now you are eligible to put your block on the network. Okay? Have I answered your question? Hello?
Ma'am, now I have a doubt. So now I am creating a transaction and I'm making a block. I'm trying to record that transaction. In that case, so the hash will be selected by itself, right, ma'am? Or the hash value I will have to type.
So no, it will be automatically created.
Selected. So the nuances, why should I select a nuance number? As you say, target or above target, you have given some numbers. Why should I select these numbers?
Because if you do not have nonce, then you have the static data. Now, as I have told you, let me just take you to the, let me just give you a demo first.
Okay, ma'am.
Give me a moment. I thought to give you at the end, but let me just tell you right now. Yeah. So can you see my screen?
Yes, ma'am.
So I have come to a blockchain demo kind of screen where you can see data and hash. Can you see this data and hash? Oh, 1 second.
Yes,
Yeah.
ma'am.
Right. So without data, you have a hash here. So when there's no data, you have a hash, right? Now look at very carefully, look at the hash. It starts with E3 and ends with 55 for no data. And if you remember, I had told you when I told you five important things to remember about SHA 256. That means it is deterministic. That means if you have a same data, you will have a same hash, right? So the moment you change the data, if suppose I write hello, right? Can you see it has entirely changed? The hash has entirely changed. A new hash is there. Now, if I make a small change, avalanche effect, if I make hello, hello exclamation, one exclamation, this is completely changed. See, without data, it is again the same. So 2-3 points which I told you, I am just repeating it once again because I have come to demo now. So it is one way. That means the data will create a hash, but from hash you can't create the data. That is one. It is deterministic. That means for a particular data, you will always have the same hash. So for no data, you have the same hash, right? Right? Avalanche effect, which is again very important, is like if I say Neha Sharma, okay? Now this Neha Sharma does not have space, but it is a data here and it has got a hash generated. I decided to give a space so that it becomes legible. So entire hash is changed. It is not a slight change. I have made a slight change in my data, but then the hash is getting changed thoroughly, totally, entirely. This is what is avalanche effect. Very important concept as far as blockchain and hash is concerned, right? Now let me take you to the block. This is just one block, block number 1, which already has some hash without data, and I add a data. Hello, all, right? Now this is turned from green, it has turned to red. That means it is showing error. I have meddled with the data. I have disturbed the data which was there. So it has turned to red. Now I have to mine again, right? When I mine, it generates one more particular hash, right? Now this hash may not satisfy the puzzle. Now suppose here, since we have 4 zeros, now suppose if the puzzle is to have leading 16 zeros, so it fails, right? So I have to keep on trying. I have to keep on trying. So it will take time. I have to keep on trying with new nonsense to see whatever target which has been given to me, it should be met, right? So this is what is the basic purpose of nonce. Everything is, see, let me just take you to my presentation once again. Is it visible? Presentation is visible?
Yes, ma'am.
Yeah. So see, as I told you, the block number is static. Your data is static, your previous hash is static. When you take this static data, you know what hash is going to get generated. And every time you will generate the same hash. And you want your system to be unpredictable, you know, nobody should be able to hack that. So you want to generate something which is, I mean, the moment you change the data, everything will get changed, you know, so that, you know, your data is tampered. Now, as far as hash is concerned, you have to qualify the puzzle. Otherwise, throughout the network, so many people are adding so much of data, right? So at one point of time, if everybody start adding to the network, without any rules, regulations, then you will not be able to control that also. So there has to be some benchmarking, some target which you have to pass, some exam, let me say some exam which you have to pass to make way for your block. Right? For example, I'll just try to make it simple and understandable to all of you. See, suppose we are 50 people here in this network, today's participant here in the network of blockchain, right? Now, I also get some transaction because we are node, we will keep on getting some information about transaction. You also get some information about transaction. So our job is to ensure that these transactions are fair transaction. First, to ensure that these are fair transaction, not the fraudulent transaction. So once you have ensured that these are fair transaction, you will try to make a block. Now, when you try to make a block, you have everything static, right? Block number is static, your data is static, your previous hash is also static. With static data, you will churn a hash which is predictable. You don't want it to be predictable. So the element of nonce has come, right? And also, this is one reason. And also you have a benchmark. All of us, we have been given that your hash, if at all, it has got 16 leading zeros, then only you can add your block which you want to add to the network. You can add it, right? So you also start making the block, trying to make the hash of the block. I also try, likewise others also try, right? Now we all are trying to get a number which will help us generate a hash which is below the that level, the target which is given, right? And it will not come in one go. Here in the example, I have shown you 5, 7, just for understanding. You will have to keep on trying. It's a luck, you know. You may get it in first iteration. You may get it in hundreds of iteration, right? So suppose you get it first. You get a hash which meets the target. So you are eligible to add your particular node to the blockchain, right? Have I answered your question?
Yes, ma'am. But my question is like, what is that we have to write nuances for? Say I'm creating a transaction. Say I have a banking customer. He is doing a export or any transaction, which I have to debit or credit. So his previous block will be somewhere. So I have to identify that block and make some changes to his account.
No, you not have to identify your previous block. See, if suppose you have a bank account, right? You have a bank account and you keep on doing some transaction, not on one day, not on adjacent days. You know, you do one transaction last year, 12 months back, next transaction 4 months back. You keep on doing any transaction, but when you add your this thing, no, it will get added to the network and it will trace it automatically. There is a link. It need not link to its own transaction previously. It will have its own mechanism to trace it. For that, you have to dive down. In that case, what you are talking is every data will also have hash. Every data point will also have hash, which can further get linked. So I am just trying to make it simple and make you understand the basics of it. So for now, you understand there is some transaction which you want to put it on the chain. Like for a bank, if a bank wants to make an entry, if suppose you want to make an entry in the register, right? So you get first customer, he took out say 5,000 rupees from his account. Then you get the next customer, he deposited 200 rupees in his account. Then you get the third customer. So here what I'm explaining you is this kind of record keeping. You can dive in and you can keep on exploring more, but this is what is the basic thing to understand how it happens, you know, the concept of nonce. And very many people will not be able to explain you this. So you have to understand that this is the only dynamic thing which changes and which ensures that your hash is unique.
Ma'am, sorry. You say that nonsense is dynamic and it is a value created by us.
Yeah.
So is it like we have a
track of these nuances in our records so that we trace that block back?
No. Which block you want to trace? Which block you want to trace?
No, ma'am. One thing you said is only nuances is dynamic.
Yes.
Is there any other use of nuances to be noted across?
No. Nonce is just helping you to create a unique hash which can meet the target. That's it. Otherwise, you will, with the static value, you will always get a same hash, you know. I have just shown you, if there is no data, you will have the same hash. So with the static data, you will always keep on getting the same hash and you will never be able to meet the challenge, you know.
So find the space in the in the hash, we use nuances.
No, come again, please.
To find the space, our space of to put our block in the hash space. That is
No, you have not understood it. See, I'll just repeat it once again for everybody. You want to add a block, you want to create a block. First thing is that now block will have your data, your block number, and you will also have a previous hash. Any doubts in that?
No, ma'am.
No. Now with this static data, I have told you right from beginning, with this static data, you will always generate this static hash because see, it's like a machine. You give an input and you get an output. So hash algorithm is a machine, right? Where you give input as a block number, data, and previous hash, which is not changing, which is static in nature. So when you give a static input, you will always get a static output only, right? Now, this static output, which is the hash of the block, may not be able to meet the target because you have to meet the target to add your block to the chain. If you do not qualify for the exam, how will you go? You have studied well, you have all the resources, but unless until you qualify the exam, you cannot go to next class. So here it is like, unless until you have a right hash, your block cannot be added to the network. So to add the block to the network, you want a flexibility in your hand so that you don't get the fixed hash. How do that flexibility come? You have to add one more element, which is any number, any numeric value. Now, when you add that numeric value, now you have 4 inputs to the black box, which is hash algorithm. 4 inputs, out of which 3 are static, 1 is dynamic. Now, with this dynamic input, when you give, you get some output. It may help you in qualifying the exam, meeting the target. It may not help. Now, if it does not help, come again back here, change this number, again run through the algorithm, get a number. So you have to keep on trying this till the time you pass your exam, meet your target. The moment you meet your target, this becomes your data. Block number this, nonce this. So this number 5012 may not be used again then. Number used only once. Okay?
Yes, ma'am.
Ma'am, a very clear concept is like whenever a new block is being added to the network, we need to create a new hash, right? And then once that particular new hash is created, that remains fixed for that particular block.
Yeah. Yes, you're asking me.
To create a new block, again a new hash will be created. And no sooner a new hash is being created, which is actually meeting our specified criteria, that will be added to our network, to a chain of network. That is why it is a blockchain. Simple.
Exactly. But one hitch here is it's not just creating a hash, it's creating a right hash.
Because that is meeting according to the target.
Yes, you have understood. Yes, and then only it can be added to the network. And this is very, very important to understand. It's not adding anything. Anything cannot go to your network. You know,
it's basically adding a correct hash. And then this particular hash which has been correctly generated is not going to change for rest of the blocks, no?
No, it will not change. No, once it is
fixed, that is going to become a static for the other blocks then.
Yes. Right.
Okay. Thank you.
Okay, yeah. Now, I have just included this Byzantine fault tolerance also as a concept before going forward towards consensus protocol, which is the fourth fourth or fifth feature of blockchain, So this is important, so I have kept it here. Byzantine fault tolerance. Now this again I am going to tell you like a story so that you understand the concept properly. So there is a castle, and the castle has to be won or conquered rather. Now to conquer the castle, there is a team of maybe army which has gone and tried to attack it from four corners. Now they have to have a strategy to conquer this particular castle, Now the strategy is that there has to be a smooth, seamless communication between all four of them. So when they all decide that they have to attack all together. And if they decide retreat, they have to retreat it together, because if they go independently, probably they will never be able to conquer the castle, right? Now, out of this four people, one is the commander, right? One is the leader, one is the commander. So who will pass the initial instruction, and all four have to follow. Now there's a possibility, and the communication is seamless, they have to have a seamless communication between them. It is just an indicator of peer-to-peer network, right? So it's not only they receive the communication, they have to verify what they have received is correct or not, because there may be a traitor in between in the army which may try to mess up the thing, So for example, the commander, the king or the leader, he passes the information to attack, right? So they have to now confirm whether what they have heard is correct or not. So they have to transmit what they have received. So this is a traitor, so he will try to mess up with the thing. So he will say, commander has asked not to attack, retreat, okay? He will say that no, I have received the information that we have to attack. The fourth one will say, yes, we have to attack, right? So commander, as he knows that he has given the instruction to attack, he will have the right information. This person and this person also, out of 3 inputs of information, 2 are to attack and 1 is not to attack. And the same goes for the fourth this thing. And the traitor also has got all the 3 as attack. So whatever he wants, he wants to play some foul in this, he will not be able to do it. So then the information is proper with all of them and they can work in a proper way, right? Now, assume that the commander is a traitor. Possible. In real life scenario also, it's possible that commander is a traitor. And it may be looking trivial to you, but this is not trivial. It is highly complex problem to handle, and lots of cryptography, mathematical computations are involved in this. This is a simplest way to explain you this particular complex concept, Now assume that commander is a traitor and he tries to mess up with the things. So for two lieutenant, he passes the information that you have to attack, and to 1 he passes the information not to attack. Now as a ritual, they have to communicate back saying what they have received. So this commander says that, okay, commander has asked me to attack. This also says that commander has asked me to attack. And this says that, no, he has asked me to retreat. Okay. So now again, you have to calculate how many attack and how many retreat. Okay. So it's like a voting system, what are the more thing. So one can be intentionally or unintentionally a wrong message, right? So depending on this, all the 3 will decide to attack, and the 4th one has to attack, right? And here is a special reading for you. If you want to read more on Byzantine fault tolerance, you can read this. It will give you a better idea. I have tried to explain you in a simple way. It's how you communicate and how to bring in the consensus in the team, in the nodes. And it is profusely used in many systems, in airplane also, where you have aeroplane, where you have so many systems which are giving instructions. There is a possibility there that one system fails, right? And it is giving something which is wrong. So you cannot take a decision on basis of information from one system, you have to take into consideration the inputs from other systems also, right? Now coming to that, that is a fundamental of consensus protocol. So let me take you to this consensus protocol now. Consensus protocol basically handles two problems. First is a challenge. Attacker is trying to attack or trying to add a wrong node or wrong block to your blockchain, right? So that is the first thing which can be handled easily. I'll tell you how. And the second challenge is competing chain. Now, competing chain is a real-time problem which you were just asking. I'll try to explain in a simple way, but it is not as simple. But I'll try to give you an aerial view from where you can see in a decent way how it functions, right? So consensus protocol basically handles two problems. First is like safeguard the blockchain from the attackers, and second is how to handle the competing chains, right? There are many types of consensus protocol, proof of work, proof of stake, and there are many more. But Bitcoin uses proof of work. So we will be discussing proof of work right now. Proof of stake is used by Ethereum because it is for smart contracts and all. So our understanding till here is clear, right? You have to meet the challenge. You have to meet the target to get your block added to the network, right? So hash has to meet the challenge or meet the target, right? So the moment you qualify, you get that golden hash, you are allowed to add your block to the chain. So you have added your block to the chain, right? And for which you get a reward also in the form of Bitcoin, which is quite a handsome reward, right? One second. So as you now in case, see here, you are also rewarded to be fair. The moment it is realized that you have done something which is wrong, so your block will be removed and your reward will be taken away. So here you are paid to be honest, you are paid to be fair. So the moment you have found out, you have solved the puzzle and you have found out the right hash which meets the target, you are allowed to add your block to the chain, and for which you are rewarded also. Now, once you have added, your peer-to-peer network will come into play and everything will be added everywhere, right? Now, it is not that easy as I'm telling you. There are many checks, there are many checks which happens before adding your block which you have added to the entire network. It does not happen in one go. It will happen to your first connect, then from first connect to your remaining connects, it will spread like this chain, So things will be, you have a long list of checklist basically, which takes place before adding the block which you have added to the entire network, like syntactic correction, duplicate C, whether verify the Merkle hash, and so on and so forth, right? The list is long. And the best part of this blockchain is it is hard to solve this puzzle, you have to keep on trying, which I told you, it requires lots of computational power, it requires lots of electricity, and it is expensive thing, so hard to solve but easy to verify. Why? Because it is deterministic in nature. You have data, you have to find out the hash, but if you have hash, you cannot find out the data, right? But it is easy when you know the nonce, right? The difficult part is to find out the right nonce to solve the puzzle. Once you know that 1536 has given you the golden hash, with the same combination you can find out the same hash again and again, right? So hard to solve but easy to verify. This is the best part of it. So I mean, the moment an attacker tries to add the block, there are so many checks and validations that he is easily caught and his reward is also taken away. So nobody can cheat. Here you are paid to be fair and honest, right? Right. So as I told you, once you see, the struggle is to get this 5012 as a nonce value. Once you get it, you have the combination of values which will always give you this hash. So verification is not a problem here. Now, second part is computing chain. Come back to this peer-to-peer network. Now, possible, as I told you, like every node is trying to save some transactions, and to start with, assume that everybody is doing a fair job. Everybody is trying to do a fair job. So it happens. It's possible because your network has got thousands and thousands of nodes. It is spread globally. So possible that in two corners of the world there are two nodes which are adding the blocks at the same point of time, right? Almost same point of time. Now they will start propagating the data to their network, right? Network is same. Now this particular node spreads the information fast, maybe because the internet is faster, the facility is faster in comparison to this part. So here this node could transmit it only to propagate only to one node, whereas this node could transmit it to 3 another nodes. Can be multiple reasons. I have given you one reason. Network speed could be one reason. Now this does not mean that these two nodes have got wrong data. It's only that they have got slightly weaker technological backup and internet connections. For that they cannot speed up. Now once all the nodes have reached to this point where they are spreading their information to each other, so they will realize that, okay, I have got this one and you have this one, both are correct, nobody is ready to retreat. So they wait and say, let's see who grows faster, right? So they will wait for one of the nodes to add a next node, right? Now point here to note is, here this chain has got only 2 nodes with purple, and here we have got double the computational power. 4 nodes are there, right? Now with 4 nodes, you are sure that they have got more computational power. They will speedily do the computation and probably will come out with an additional node, just because they have got more computational power, not for anything else, right? So they have added a new node and they have propagated. So they have to back out and they just drop the node which was added and they replicate this. So though these 2 purple nodes are fair, correct, but still they are orphaned, and the reward which was given to them is always with the block, so it is also taken away. So you have to ensure, so that's the reason people ensure that they have got good facility if they are working as a miner, right? So this is how the computing chain problem is resolved. Now coming to the last section of our talk is Bitcoin. I will just quickly touch upon this. It's like there are 3 layers. First layer is technology, second layer is protocol and coins, and third layer is token. Now technology is the underground fabric which allows you to do new things, which allows you to experiment on new things. So underground fabric is nothing but a blockchain. The concept technology is the blockchain. Now protocol, we all know the protocol is a set of rules and regulations that allow participants to communicate with each other over net, right? So when you have a technology, you will like to have some protocol which will allow you to use that technology. Like IP, Internet Protocol, allows you to interact on the internet. HTTPS allows you to have your website proper on your browser. So all those things, protocols are there to help you in presenting yourself or communicating properly with each other, So cryptocurrency or coin means a blockchain-based electronic money on the distributed ledger, right? So when I say Bitcoin is a protocol then, right? Which is built up on the technology called blockchain. let us see what is Bitcoin. Bitcoin is not just a coin or currency. It's a set of protocol to help the participant of Bitcoin blockchain network to communicate with each other and agree on things. Bitcoin protocol dictates. What all it dictates? How can we come to a consensus? How public keys and signatures can be used for authentication? Agree on update of protocol itself and other things to update efficiently. So it's basically rules and regulations which allows you to decide what has to be the way forward, you know, how we are going to, if you are saying something, what does it mean, so that it is not misunderstood by the general public. Then public key and signatures for authentication, all those things are taken care by this protocol. Okay, public key, private key, and all those things are there. Now, because of paucity of time, I will not be touching on public key, private key concept. I'm sure somebody in 5 days would be, because that's again an important concept, somebody would surely touch upon that. So there are many protocols available, like Waves, Ethereum, Bitcoin, Neo, Ripple. Now, these protocols, which is a set of rules and regulations, independent, there are many, you know, everybody has got their own understanding and own way of using the technology. So they have come out with their own protocols, right? But one thing is common, that every protocol will have their own coin. So protocol contains within them an important feature called coin. Coin is an innate asset of the protocol which facilitate the interaction amongst the participants, award to the people who are mining, adding blocks, purchases. So the protocol will have some mechanism to incentivize the people who are playing fair, right? So every protocol will have a coin with them, right? Waves will have something. Ethereum has got Ether. Bitcoin has got Bitcoin, Neo, and Ripple. Every protocol has got coin associated with that. Now, when you transact using the cryptocurrency, it has to be maintained somewhere. Okay, so every protocol will have their own transaction log, where how many bitcoins you have given, how many ethers you have given, how many ethers you have received, how many ripples you have received or given, has to be maintained. Okay, so as I said, every cryptocurrency has its own transaction log. For example, Bitcoin has its own blockchain, Ethereum has its own blockchain, IOTA has its Tangle-based distributed ledger, so on and so forth, right? So in short, you can say that coin is a ledger where you maintain all the transactions. Now, coming to tokens, right? Ethereum has got many tokens. What are these tokens, first of all? Now, tokens are nothing but initial coin offerings. Like you have, when you launch something, you have some initial offerings, you know. So you and it is like in subsidized rate. So here also, in this digital currency forum also, you have initial coin offering, which mainly relies on smart contract, which are built on the top of protocol layer. So you have technology layer, you have protocol layer, and then you have token layer. So it is basically built tokens, which is initial coin offerings, are built on protocol layer. The quantity of cryptocurrencies sold in the form of tokens to the investors in the exchange of legal tender or cryptocurrency such as Bitcoin or Ethereum. Hundreds of tokens are there. So basically, how you deal with them. So if you have a customer, you have to give them some benefit. You know, you give them benefit in terms of tokens, which keeps on growing, which are nothing but ICOs. Right. So Ethereum, as it is in smart contract, it has got many tokens. Waves have got some token. Bitcoins have got tokens in different way. You know, Neo has got tokens. Ripple also has got tokens in different way. Let's focus on Bitcoins. So Bitcoin tokens is a digital currency. Basically, it uses peer-to-peer technology to operate with no central authority or banks managing transactions to carry out collectively by the network. There is no central control over tokens. Bitcoin tokens are open source, community driven, and decentralized. So anything which you do good, you say any block which you mine, which entitle you to earn a Bitcoin, you know. So that's how it says that it is open source, community driven, and decentralized. Once the transaction ledger has been created, it is necessary to issue tokens that are actually exchanged among cryptocurrency users and whose exchange will be transactions stored on the distributed ledger. So you have to make a record. Whatever you give or take, you have to make a record, and the record is maintained on the distributed ledger on the blockchain itself, so that it is transparent, it is shared with everybody, nothing to hide. You can visit coinmarketcap.com to understand how this token, coin, and all those things are working. You know, you will get a first glimpse of it. I don't have time, otherwise I would have shown you. So everything very clearly, what is the market share, what is token, what is protocol, coin, and you can see everything, you know. Now, when you are investing in coin, that means you are investing in a protocol, right? And if you are investing in a token, that means you are investing in an idea. So whatever you say, like there are many industries who have adopted blockchain, like healthcare, logistics, supply chain. So they are building on the top of protocol, you know. So the bottom layer is technology. Above that is a protocol. They are using the protocol. That means the rule and regulation to communicate, to build an application which will nothing but generate multiple tokens to invest on the idea, right? So it is like that. So what is Bitcoin? Of course, it is built up on the technology, and the technology is nothing but blockchain, and they can transact in a transparent and unbiased manner with each node in peer-to-peer community. And let's look at the ecosystem of Bitcoin. It's like you will have a node that's single point. The smallest factor in the Bitcoin ecosystem is a node. Of course, it is shown as a human symbol, but it is not a human symbol, but it's a machine, laptop, whatever you use can be part of node. So you have miners also, which has got heavy systems, strong systems, to do those computational things, you know. You have large miners who has got big setups. They have set up dedicated setups to just keep on mining, and then few miners can come together to make a pool of miners, right? So in your ecosystem, you can be anything. The idea is to add your block to the network, and the block has to be correct. It should be first, because if it is added first, it has got major chance that it will not be orphaned, right? So if you want to read more about this, you can actually go to the original paper by Satoshi Nakamoto. Very beautiful, very simple paper, Bitcoin, a peer-to-peer electronic cash system. Must read if you want to pursue blockchain and Bitcoin. For knowledge also, you can read it. Now, blockchain and data science, how it is related, I would just like to say for 30 seconds, like as I told you in the initial slides, if you remember, there are so many technologies coming up which are generating data, and then you also have a technology which allows you to help you to get the insight from the data. Data is being thrown to you from all over, and blockchain helps you in securing the data, ensuring the data is not tampered, not any kind of fraud is performed on it, and so it becomes a part of data science, so directly or indirectly. And I have to say that the future of data science is very, very bright. You are going to have increased number of roles. You will have a clearly defined scope for data scientists. You will have more jobs. You will have it included in the school, and you will have more advanced AI and ML concept to foster data science. Society for Data Science, which I told you initially that we have formed in 2018, is working towards bringing all the people. It does not matter whether you are a very senior corporate person or a beginner or a professor or a student or a researcher. Anybody who wants to play with data are most welcome to come here and work with us. And we will I mean, anything innovative if you have in your mind and you want to, you are not getting a platform to do it, come to us. We will help you to showcase and help. So the objective of this society vision and mission is to ensure that responsible use of data is done for the benefit of the society, enhance the capability of everybody to solve the larger problem, societal problem. Corporates will have their own problem and they will solve it also. But then at times they come to academia, they give a societal problem to academia to solve it, and that is opportunity for us to actually look at. And basically we should start looking at the open data also, which is available in abundance around us. You take data.gov.in, you take your municipal corporation data, you start handling that, try to find out what any insight is there which can be beneficial. I'm sure you will start enjoying that. And we are basically trying to emphasize on multidisciplinary approach, wherein you don't work in isolation, you come together and work together, right? And the objective of the society is to actually create a think tank, have good alliances, strong alliances, have good data science solution, I mean, feasible data science solution for the critical problems, real-time applications, center of excellence, have certifications. Now, these are few indicative objects. We keep on updating our objectives also. The moment we achieve one, we add two, so that is the way we work. And last but not the least, as a society, we have been organizing international conference, and this is the 5th time we will be organizing in the month of January. And this will be virtual. Of course, this flyer, when this was made, it was decided that we will be doing it in Science City, Kolkata. But now, since this is a pandemic situation, we don't want to risk anybody's life. Of course, the call for paper is all over, and there's no way, but you can participate and listen to the work which people are doing in the field. And we have got many papers related to blockchain also. Mainly it's around machine learning, artificial intelligence, data management, and so on and so forth. And you will enjoy, I'm sure you will enjoy listening to the keynotes, you will enjoy listening to the research work, because listening to the research work is equally important to get an idea from where you will start your research, right? Only reading does not help. And apart from that, we have very good list of keynote speakers. You can just visit the website. I mean, the best of the world, they come here and deliver the keynote. And apart from that, we have workshop tutorials also. The first one is on 19th of December, which is coming Saturday. There we have 2 topics, very interesting topics by grandmasters, they'll be delivering, and 2 workshops and tutorials are there on 15th of January. So we have separated out so that most of the people can take benefit out of these deliveries. So in case if you are interested, go visit the website, and at least what minimum you can attend is like workshop tutorials. And of course, there's a opportunity to listen to the papers also. So that's what I can advise you. I personally keep on doing it, and I keep on advising that. So thank you so much. And let me just, before I close, let me just show you one more demo. I mean, the advanced part of it. So I showed you this block. Now this is just a demo site. Do not take this as a final concept. Do not confuse yourself. Let me show you blockchain. Now this is a chain where you already can see the 5 blocks are there. 5 more blocks are 1, 2, 3, 4, 5 blocks are there, and they have got their respective hashes, right? And nonces also. So something is fixed. Now you can see that all are green because you have all cryptographic correction. Now if I change this, say if I write hi, right? So since I have not mined it, it has got disconnected because the hash is changed. And since the hash of block 1 is changed, it is not matching with the block 2, and subsequently rest all the blocks are out of the chain, right? So the moment I mine this, you can see this has become correct, but this has not become correct. You have to explicitly do it, right? Let me just put some data everywhere. Right? So I have put some data everywhere. Now I have to mine it. You also can go to this link and plug and play and see. But this is just for learning purpose. There are many concepts like nonce here. It does not allow you to change the nonce manually. Whereas in real scenario, that is the only element which has to be changed by you, right? Since the concept is complicated, Andrew has designed this for better understanding of public, Now, so everything is in sync now. So blockchain is untampered now. So you can see this is the genesis block. All previous block hash is 0. And the hash of this block is this, which is the hash of previous hash of the next block. And likewise, it is all cryptographically connected, right? Now, if I make a change in this, unchain the blockchain, right? So the moment I tamper with the data, all the nodes are out of the chain, right? And then you will have to mine it again too. And this is only, I'm repeating, this is only to understand the concept. In real life, it is not that simple, and you do not have anything like this. This is just for making you see what we were trying to say, right? And there are many more things I can show you in distributed environment and all. So you also can see it for yourself. In case if you have any question, I can take it, because